Right. So welcome back again to this image processing laboratory. This is the third lab, if I'm not wrong. And this class, what I thought is last time you had in your assignment, which was based on the histogram, you're doing segmentation based on thresholding, where you were choosing the threshold empirically, right? You are manually looking at each threshold value, possible threshold value for your intensities, and you are picking it up. So I thought as a part of this image processing laboratory, you can have one simple lab sheet where you could in fact use know one of the thresholding selection methods, one of the very popular methods, old method but still widely used method. I would like to introduce you to Otsu thresholding here. Okay, that's what we will do in this class. Followed by that, I will also explain you about the programming assignment that you need to do on this Otsu thresholding. So before that, any questions from the last class? Are there any questions to you from the last class? Hope everybody is able to do the last class. I mean, the last programming assignment. Okay, I hope things are fine. So then let me move on. I thought I would start showing you the results, then followed by that I'll explain you. This is Otsu thresholding is available as a built-in command that's gray threshold. This is the command that it will give you. For example, this is your input image, right? So this is again nodules. There is a inbuilt image is there in your MATLAB, inbuilt in the sense in the default directory it is there. So IM read, you read that, and then if you show that image that this is how it would look like, and then the threshold will be able to pick something like this. Now all you need to do is Tn equal to gray threshold. So it's like on a grayscale image you are applying this threshold. So if I'm maybe you just need to check out that this image might be taking just a 1D image. I don't know whether, or you just look at the help information for this command. Then it is also whether it takes 0, 1 normalized image or 0 to 255. That also I haven't checked myself. You can check it. But perhaps this threshold it would give you on a normalized image itself, which is 0.58 here. Okay. So this is the one. This is another image, rice.tiff. Okay, this again is a there in the default directory of your MATLAB. So you could perhaps directly call that, or if not, you could put it in the current directory and do it. So then if you do that, you will get this. Okay, this is how it is. If it looks like it might take yeah, you just check with this help message on what it takes. Okay. Right. Another example before I go forward. Here also you could expect in the histogram, all the background of this text could have one distribution, and from there, from gray to black, you can see a transition there, correct? So here again, gray threshold will, if you do and put it, you will be able to clearly distinguish background versus foreground from your image. So this is what it does. These are some sample results that you would get with the Otsu thresholding method. Now we will go into some details about this method. Okay, before that, any of you have any thoughts to share? Any points to make? Okay. See, now this is not the only method. That's what I want you to keep in mind. That helps you to find out a threshold based on histogram. There are quite a few methods. For example, there is some global thresholding similar to Otsu thresholding. Will be looking at the variances of different classes, how they are separated, or how far or how close they are. But you might be using, if you even go to ImageJ tool and yeah, look there for segmentation, threshold based segmentation, you will get not less than dozen methods there. Okay, ImageJ, you could take a look at into that. ImageJ. Okay, there is another extension to it. I immediately cannot recollect the name. There also there is, you would see quite a few methods implemented there. So there is a rich class of methods. So like, in fact, on segmentation and thresholding in particular, we have spent around maybe 3 classes or so in the medical imaging course last time. But now I don't want this to also again become a theory course to you. So I just picked up only this Otsu thresholding alone. Okay. Yeah, Sindhura, yes, you can do that, or you can do it after the class also. That is fine. I'll just show them the images, the from the Google Doc. I'll show them. Then after that, you can upload. That is
Sure.
also fine.
Okay. Okay, sir. Carry on.
Yeah, yeah. See, now you have 2 classes essentially. Look at them as 2 different distributions with different mean values and variance values. Now, I give you, let's say, one distribution is like this. Okay, be it either background or foreground. The other is this. Okay, so or maybe just I will draw a bigger one. Anyway, again about these distributions, once we are done with this image processing part in our course, we will discuss in more detail. But let us just have a quick look at this. Right. Suppose I have 2 distributions like this. I know the individual distributions of intensities. Okay, that means I have here the intensity value versus number. You call this as the PDF, for example. Okay, or equivalent of PDF. Right. Now, which would be a good threshold to distinguish? Let us call this also, let's say your object is at a low intensity and your background, or typically background may be at low intensity, and this is your object. Okay, so how do you choose a background? How do you choose an optimal value till which intensity one? So essentially now what we want to do is take one intensity, figure out or pick one intensity such that anything before that intensity, this I myself wrote it so badly, let's call it BKG for background, object OBJ. Okay, so I would say this also, let me give you, I would choose this intersection point as my background, and I would say anything before this as my any intensity, let's call this value as R. If the intensity is less than R, it's background, and more than R, it's object. Okay, or more than, somewhere you put equal in one of those equations. Can you comment in terms of errors? What is it that is achieving if I'm doing it this way? What is it that you are optimizing it? When I'm doing such a kind of allocation of intensities to background and object, can you comment on what is essentially perhaps we are optimizing, or what, any thoughts about it? Or do you think of any other thing?
Yeah, it is type of a probability of error in the communication.
Right, very good. Yes. So what is, can you shed some light on what kind of error, like what is it that is getting minimized here?
Like suppose if you want to get only object image of object,
Mm,
we should get a less amount of background in that.
right. So probability of misclassification errors, right? That is what you are minimizing here. Pay attention here. And if my explanation is not clear, no, do raise a question here. See, when I took this intersection point and gave it, suppose if the probability of a pixel having beyond, look at this here. So the probability of a pixel belonging to an object but assigned to a background. So probability of, I'm not writing in the formal way at this point, but we will do it later in the course. It is actually the object is the pixel is belonging to the object, but wrongly assigned to the background. So which would give me that value? How do I know?
Left side of threshold point.
Left side of threshold, what is it that I should look at there?
I mean, the left side of object PDF.
Okay. So can you
left to
just
the
give me the formula there? I put, let's say this is 0, this is R. For example, this I would call it as, for simplicity, right now, let me take just as 1 here. Okay. Now can you quantify the error? What is the probability of error that an object belongs to, sorry, a pixel belongs to an object, but is assigned to a background? Or tell me in terms of areas of the curves. So let's call this as probability of object. Okay, this is as probability of background. Now you tell me what is the error that you could commit here while you assign from this intersection point, you assign it to an object.
Sir, we can call it integration of object curve from 0 to R divided by integration of image curve
Use
from 0 to R again.
no. Any other thought? But like me, you also have afternoon after lunch effect. Would like to hear some answers here. Areas under the curve, you tell me in terms of that errors. Let me also
So
call it,
you
for
want
example,
the area which has been wrongly read as image, but it belongs to object, right?
right, correct.
So,
That is probability area under that will give you the probability in a way, right? It's a PDF. So you tell me
so
from from where to where I should take that area will give me the probability of misclassification.
object curve will integrate from 0 to R, sir. We will get the
Right.
area.
0 to R integrated this object curve G2 will give me the probability of misclassification. Suppose instead of here, you observe here, any point on this side of the curve, suppose if I have assigned it to an object, is the error more or less? Probability of error is more or less. This value, if you look at it as probabilities, here the probability of that belonging to an object is less compared to that belonging to background. Do you see the difference there? Do you see this distinction here? Similarly here, after this point, the probability of that belonging to the background is this, that is less compared to it belonging to the object. So that's why you are assigning to an object. It's one way of doing things. And it is at this point to whichever you assign, there is an equal probability of committing a mistake there, because there are set of pixels in object as well as in the background, which are having the same intensities. Am I making any sense? Is that clear? Any comments on that? Okay, good. So any other, is everybody able to follow that? Would like to hear few more voices as usual.
Yes, sir.
Okay, good. Then it is fine. See, now let me just erase this all and come back. Right. Now, see, we do not really know the distributions independently here. The mean and variance and all these things we do not know here. What you have when you draw a histogram is what you see in B. Then there are instances, for example, here, if you look for a minimum here, that will be somewhere here. On the other hand, the calculation I told you will be somewhere here. And things are even more complicated when you have distributions like this with a good amount of overlap of distributions. You can't really see where to find a minimum. So the message here is that just going through the histogram and they're trying to find out where did it hit the minimum may not always work. Is that message clearly conveyed through these two diagrams? Are any questions there? Okay, so what the method that we are going to discuss is referred to as Otsu thresholding. As I said, quite a few methods are there, not less than dozen of methods already available in most of the tools. But again, we do just Otsu here. Many a time you see it, quite a few occasions it is used. What it does is minimization of within group variance of the two groups of pixels separated by the threshold. So what does it mean? If I had picked, so I take a distinction that this till from the histogram. Okay, I have a histogram here. Let's say some histogram is there. Now choose a threshold. For example, I'm choosing a threshold here. Then what I do, then assume that this is background or object. Anyway, the goal is to separate them, so it doesn't really matter. So let me just write this as the background. I would say this as the object. Now, if I give you that this is my threshold and this information from here, can you compute the mean and variance? I give you this histogram. I tell you that this is my intensity. I tell you that I naught as a threshold. So this is background. Anything less than that, anything greater than or equal to is an object. Can you compute to mu of background and variance of the background? Is there any problem with that?
No, sir. We can compute.
Right. So for example, in the histogram, don't even consider a PDF. Okay. My y-axis is number of pixels. My y-axis is number of pixels. Okay. Now let's say this starts from 0. Okay. Now tell me what would be the mean value of the intensity. I'm just giving you the histogram. Okay. Which is a kind of, as I was saying, summarization of your input, all the intensities that are there in the image. So how do you compute the mean value of the background? Maybe you want it, let's say, let's call this as this I na. Let me call this as h of I for each one. Okay. This is varying from h of 0 to h of I naught. Now you tell me, how do you compute the mean value of the background intensity is? Very simple question. How do you compute? All I'm asking is, for that part from 0 to I0, what is the mean intensity value? So if I take I0 as the threshold, I get a set of pixels, correct? For those set of pixels, they have intensities. Now you tell me, how do you compute the mean intensity value? At least tell me in words first, then we write expressions for it.
Summation of product of intensity and number of intensity occurrences.
You mean in very good. You tell me now. Can you tell me now in expression here? Summation you want me to keep, right?
Yeah, summation and intensity value and into number of occurrences of that intensity value.
Yeah, you tell me that now. I gave you the parts here, right? You tell me now. H of, let's say you want me to take something like P here, just to have different variable. P from what to what I should vary that?
1 to I0.
0, let's take also. So
Yeah,
0 to I0. Okay, then what do you want me to do?
Now
P into H of
P into H of P.
Right, H of P into
P.
P. Is that enough to compute the mean value?
Divided by
total
summation
number
of P.
Very good, very good. Divided by, can you tell me what is that value? Divided by?
Summation of P.
Summation of?
P.
HP,
is that
sir.
P or something else?
No, number of pixels, no, sir. So HP
Yeah, how do I
till
get number of, number of
H-
pixels till that? So how do I get that number of pixels?
HP till I0, sir.
H of P,
Till I0.
I is varying from P is varying from 0 to?
I0.
Very good, very good. You are just going to count there. That will give you the mean value, right? See, I'm saying in this class, 5 people got 70 marks, 5 people got 80 marks. Okay, for simplicity, assume there are only 10 marks. There are only 10 students. I am asking you, what is the average mark in your class? What will you do? 5 into 70 plus 5 into 80 divided by 5 plus 5, 10. That's all you will do. This is exactly what you are doing. Total number of students is 5 plus 5. So each one, for 70, there are so many, 80, there are so many. So 0 to 80, you are doing it. That's what you got it. So 5 people here got how much? H of P. For example, they got for P equal to 70. For example, there are 5 students. So 5 into 70. Next time 5 into 80. That's all you are doing. This is equivalent to going all summing up the pixel values divided by total number. Right? Is it clear to everybody on how from a histogram to calculate mean? Right. Next question. From the same histogram, now I want you to compute the variance value. Is that possible? Can variance be also computed from a histogram? How do you compute variance? Of course, possible. So how do you compute the variance now? You tell me that. I give you now new background there. Okay. Now you tell me, how do you compute the variance? So you first tell me whichever formula you know for variance. Sigma square equal to? Yeah, let's write maybe here. Sigma square equal to, how do you compute?
Summation of X minus
Whichever
mean
formula
whole
you know,
square.
first you tell that. X minus xi,
Mean
let's say.
xi minus mean whole
mu
square.
whole square. Let's say I is varying from 1 to n, let's say. Is that all or something else? Is that good enough for a variance? Or am I missing some other term? I'm sure you all will be knowing the variance formula. Is that variance or
whole divided by n?
That's all. 1 by n is there here. Correct. Right. Now, mu background, you know it. Correct. This n, you know it. Number of things, you know it. But now you have it in terms of the histogram. Now, can you tell me how you compute that now? So I will again, let's go back to this slide now, since there is something there. Okay, 1 divided by number of pixels, I would already keep that there. Okay, 1 by xl, I keep pixel, I will keep. Now your p is varying from 0 to I naught. What should I have inside? What should I have inside?
P minus mu p.
Very good. Q minus mu, let's call it as mu background. Okay, that's a constant, right? P minus mu background. What next?
Whole square.
Right. Then anything else? Is that good enough?
Number of pixels.
Right. You tell me what is that? Is
H
that
of
number of pixels?
H of p.
Very good. H of p will come here. Because it's a simple thing. When you are writing this, you are just clubbing together those pixels which have same xi value. There are 4 such things. That is what your histogram is giving you. So instead of going from 1 to n, if you have assumed that you have some k possible distinct intensities, all you are reframing or you are rewriting that equation as 1 to k, and then putting that multiplication factor of number of pixels here is giving by having that as h of p. That's all. So simple rearranging of your terms, right? So given that you know this, you can also do the same thing for the object. Any questions so far? Is that clear? Right. Okay. Then
Yes, sir.
what this tries, what the Otsu thresholding tries to do is, each class, when they are, assumption is that object and background can be separated by a particular intensity value, and it is such that they are compact in their own way. It doesn't spread too long. The variances, okay, are very compact here. What is that variance? Within group variance, you are very compact within that group. Okay, for example, let's say you have kept all people by height from LKG versus some 5th class students. You are assuming that how they are separated now is LKG students versus 5th class. The variance of height within LKG is small, and similarly within 5th class, from where you have taken a cut here, is compact. Okay, in similar lines you are doing here. Well, here you how do you take two terms together? Is you give a weight for this background which will be equal to number of pixels for the background divided by total number of pixels. So that's how what the weight you give for two weights are there, right? So maybe it will be clear to you if I show you something here. Say here, I take sigma b square, sigma f square. Weight for b is number of pixels belonging to the background divided by total number of pixels. And of course, then WF will be equal to 1 minus WB. That's the proportion. So 1 minus WB, sigma B square and sigma F square. Now, you do a exhaustive search or an exhaustive workout of all possible thresholds, and now pick that value as a threshold for which this within class variance is minimum. Each is very compact in its own group. And then you are those are the sigma b square and sigma f square. Then you are just adding, you are just calculating one group. See, because if I have this a group like this, and if I just put my cutoff here, of course this group is very small. And other extreme is, if I put just one here, of course the variance is 0. So you are giving a weight based on number of proportion of pixels that are there in background and proportion of pixels there in the foreground, and then summing up. Is the intuition for Otsu thresholding clear? Or are there any doubts? Any questions or doubts here? If it is clear, then I will take you through one example. So is that clear?
Yes, sir.
Very good. Right. Now, I'll walk you through one example. This is again, I'll share you the page also from where I have this has been taken. This is some lab book is there. So this has been taken from there. So I can even put that in chart so that you guys can have a look at it later. Okay. So for now, I just open this. Right. See, this is the same example I'm taking and making a calculation here. See here. First, maybe I would just move on. I have taken all these images from there only. I'll come to my slides so that I can write something. Okay. This is my image that I want to segment into two portions, two partitions. Okay. In one or two parts. It is a using 6 levels of intensities are there in it, 0 to 5. It has been plotted, histogram has been plotted. This is the histogram. One nice thing that has been done while plotting is the corresponding intensity color is also shown, easy to then comprehend with that. Now you need to figure out what would be an ideal cutoff. Okay, suppose if you just look at minimum, it looks like as if 2 might be minimum, but you don't really know whether you should keep 2 into foreground or background. Okay, that's what it looks like. But now let's make an analysis of it in terms of minimizing within class variance, right? So how do you do that now? The process is very simple. You start with each intensity of 0, 1, 2, 3, 4, 5. You use this as threshold. Anything less than or equal to 0 is one class. Greater than 0 is another class. Then for each class, compute the mean and variance. Of course, you are computing mean because variance requires the mean. And other class also compute the variance. Then you compute within class variance, whatever we have mentioned, WB into sigma B square plus WF for the foreground into sigma F square. You repeat this exercise for all possible intensities, then pick that value of intensity for which this quantity is minimum. Is that clear? Any questions here? Is the process clear? So we will see again, just for one value, we'll show you here, right? Where the intensity threshold value is taken as 3. So less than 3, that means is background. If less than 3 is background, of course, then greater than or equal to 3 is foreground. Now, this is what had happened here. You had then follow me carefully. If you get stuck anywhere, do not hesitate to stop me and question me. Okay. So in this, let us now this part is what we are going to analyze to compute first within class variance for the background and also the weight for the background. WB is very easy to do. Let's do it first. So total number of pixels, how many are there? You could well see it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's a 6 by 6 image. So 36 pixels are there. Of course, I could have done it by summing up the whole histogram, right? And that also I can do it, right? Now, I'm just showing you the calculations for this threshold of 3. Now, 0, there are 8 pixels. With 1, there are 7. With 2, there are 2. There are 17 pixels here. So 17 by 36 will give me the WB value. That's what 0.4722. Now, next step is I will compute the mean value for the background. How do I compute? There are 8 pixels that have an intensity of 0. There are 7 pixels which have an intensity of 1. And there are 2 pixels that have an intensity of 2. And of course, we already know the total number of pixels here are 17. That will give me the mu background. Okay, that turned out to be 0.6471. Then what? You are going to compute the variance. How do you compute the variance? There is, you have written it earlier. So x minus, so total number is 1 by 17. I would keep it out. Now, well, there is an intensity of 0 here. So x minus mu I have to do. This mu I got it as 0.676471. X minus mu whole square I will do. Such things I have to do. This 0 is for 8 pixels. So this I would do for 8 pixels. Then I have pixels. My value of pixel intensity is 1. Whereas my mean is 0.6471 whole square. And how many are there such pixels? 7 pixels are there. Then the next intensity value is 2. 2 minus my mean value is 0.6471 whole square. How many such pixels are there? 2 pixels are there. This is my variance. Is that clear? Are any questions here? Is everybody able to follow me?
Yes,
You are
sir.
going to implement this. So do stop me if something is not clear. It will help you. Okay, right, good. So I do the same thing now for foreground. Okay, now 0, 1, 2 are taken. So 3, 4, 5 will come here. Same calculations here, but now you will do for the other thing. That's all. So you got here a variance of 0.5152 and a weight of 0.5278. In other words, I could say 52.78% of pixels are there with this threshold in the foreground, and 47.22 pixels are there in the background. And this has resulted in a variance of 0.4637 for the background and 0.5152 for the foreground. Now, as I said, WB times sigma B square plus WF times sigma F square. You got 0.4909. Okay. Now, this what you have seen now is for a threshold of 2, you have seen it. Okay. In the same way, so what was 1 minute? So this was 0.4909. Where
Threshold
is
was
that?
3
This
only.
sorry. Threshold was 3. Okay. So that was anything greater than, yeah, it was threshold was 3. You repeat the same thing for thresholds of 0, 1, 2, 3, 4, and 5. All of them. So for example, what does 0? So less than 3 is foreground, correct? That's how we have done it. 0, 1, 2 are there. So here less than 0, okay, is your background, less than 1, less than 2, less than 3, less than 4, less than 5. Okay, all possible things you have taken here. And you look at finally the within class variance computed, and you will see that 0.4909 will, out of all of them, whichever is minimum, that's what you pick. And if you look at the result, that has given you something like this. So this dark thing, so this part has come. Similarly here, something like this has come here. And of course, this whole block has come here. This seems to be a better representation that you are getting there with the Otsu method. That's the best that Otsu can do. Clear? Is that clear? Or any, this is what you are going to implement, but not in this way. I'm going to tell you a much easier way how you could implement that. But before going that, this approach should give you a better intuition on how Otsu works. But when it comes to implementation, we will discuss one more extension to what we have discussed so far. So before I go there, any questions so far or any doubts so far? Now anything
Sir,
greater than
is Otsu,
yes, sorry.
sir, is Otsu the best one, or are there any other methods for getting threshold
Otsu?
point?
Can you
Is
please
Otsu the
repeat?
best one? Is it the best one to get the threshold point, sir?
No. It's not the best one, but sometimes it is enough. See, again, it largely depends on the way your image is there. So we had, if it is the best, this is actually is just for thresholding. Thresholding alone, thresholding itself is not at all good in many cases. As I said, there are more than dozens of methods. It depends on the content of your image and the context that which is your object of interest that you are looking for. This is just one of the purpose here is to introduce to one of these methods which is commonly used when it comes to thresholding based segmentation. But as I said, for example, entropy based thresholding also you can do. In similar lines, there are quite a lot of methods. So I'll try to upload my last year videos also onto the YouTube. They were there in a Google Drive, where we have discussed even threshold selection, also the global threshold selection, iterative way of selection, and quite a few, 2-3 methods at least we discussed. Even that is not exhaustive. There are quite other methods also. But you cannot uniquely say that this is the best here, because it depends on your content of the image and also what is it that you are looking in that particular image. Is that fine?
Yeah, okay, sir. Thank you.
Good. Any other questions, thoughts, doubts before I move forward? Okay, then I'll move. In practice, you will not implement it this manner. If you slightly rewrite this equation, you would realize that in fact you could altogether avoid computing the variances. I will not go into the mathematical details of it. You go through any standard textbook or any other resources that will help you do this. I will just get away with some intuition for the time being, because this anyway purpose is for you to implement some hands-on thing and get a feel for it. Minimizing within class variance will be equivalent to maximizing between class variance. Okay, maybe it looks like a jumbling of words unless I define what it means by between class variance. Is defined as sigma p square between class variance. You compute the whole variance of the entire set of pixels. Okay, you don't put any threshold there. For the entire image, you compute the variance. And if you are subtracting that variance from within class variance. See, at least it is clear to you now that within class variance is what we want to minimize. When this is minimum, is it not for a given image sigma square is constant? So can I, if I define now my between class variance as sigma square minus sigma w square, now can I not say that the problem is now about maximizing the between class variance, because that is what I am within class variance, I am subtracting from the whole variance and I am referring to that as between class variance. So is everybody able to see here? Minimizing this so-called within class variance would be equivalent to the newly defined between class variance, which is obtained by subtracting that within class variance from the whole variance of intensities computed over the entire image. We are subtracting a quantity here. This is a constant here. This, if this is minimum, obviously this would be the maximum. I think it's simple enough for you to grasp here, right? Now,
Yes, sir.
to use this simply and substitute there, and what you would end up after making this, you could try as an exercise if you are interested. What you will end up is this between class variance is equal to the proportion of pixels with the background multiplied with WF, the proportion of pixels that are there in the foreground, mean value of background minus mean value of the foreground, the difference squared. Thanks to this, you could avoid all those variance calculations. It is good enough for you now to compute the mean values for the background and foreground, the proportion of pixels that will be there in the background and the proportion of pixels that will be there in the foreground. All you will do now is simply this calculation instead of this calculation. And then you would see here, these are the between class. This is just for your comparison. It has been given. If you simply subtract from sigma square, the sigma w square, this would be equivalent into the second row. You will not do the calculation this way. Make a note of that. Rather, you calculate that based on this proportion WB, WF, okay, which were there here. I am sure you remember that WF is here. We calculated. WB we calculated. Mu B we calculated. Mu F we calculated. That is good enough. No need to calculate sigma B square and sigma F square. Don't worry about minimization. Look at it as a maximization problem and use those you take the difference of means, square it, multiply with proportion of pixels in the background and proportion of pixels in the foreground, and pick that intensity, that threshold for which this value is maximum. Is that fine? Is that intuitive? Right? Okay. So one more image I'm showing. This again, I picked it from the Gonzalez textbook. There is some method for choosing as global threshold method that would give you this. Anyway, rather than that, you would be getting here results here. Suppose, as I said, if what you are looking in an image is different, then probably this is not the best one to go for. But maybe you could revisit these images now once again and see that in such cases, there are some instances, good number of instances where this will does a decent job and typically good enough for you. Okay. So all you need to do in your programming assignment, we made it even simpler this time, is you write a function. Okay, you'll go to that will be uploaded after we discuss, because if there are any clarifications sought from your end, we will make that also here, and then this will be uploaded by our TS. Okay, see, what you need to do is you write your own MATLAB function to perform Otsu thresholding. What should it take as an input? Simply an image has to be taken by it as an input. Okay, and we give you few inputs. By the way, I could also show you some results that they have got for some of the images there. Okay, this is the image of a building. This is what they are getting. You plot the histogram. This is the threshold that it has picked up. This is another image. That's what it has picked up. It's with snow and trees. Well, snow is white, trees are black. With sky also is going into these two are going obviously into one class, and the rest has come into other class. Again, you could do multi-class segmentation also, not just two class. Anyway, I'll not go into those details. If somewhere there is a requirement, or if you are interested, you could read further on that. So we will just right now focus on just two classes problem. Okay. Now coming back to the assignment here, you need to write your own MATLAB function that imitates what that whatever command I was mentioning. What is that gray thresh does? So basically, it should take as an input the image. So what does that? What should that function do inside? For that image, it has to compute the histogram. After computing the histogram, you should figure out what is the minimum and maximum values of intensities. Then you take each intensity value, each one as your threshold. For that, you compute the between class variance, because that is easy to compute. That means again, you will be computing WB, mu B, WF, sigma F for that particular threshold. And once you compute this between class variance, you store it in a vector. Then you move to another one, another threshold. Okay, for all values of intensities that are there, you sequentially go. If you have assumed 0 to 255, you create another vector of 0 to 255, where you will be saving the between class variances for thresholds from 0 to 255, or I don't know, 1 to 250, 0 to 254, or whatever it be there. Okay, you do that. In this array, you figure out what is the maximum value that you have. You look at the index of that. From the index, you can figure out what is the intensity of that. So that you take it as a threshold. So what should be the output of your program? It's a function you should write first that takes an input as a image. Okay, and I would say it should give you an output image and the threshold intensity value. Histogram you can plot outside. Vaishnavi or Sindhura, histogram can be plotted outside, right? So they could call that function, get the image, and then plot the histogram.
Yes,
Is
sir.
that fine?
Yes, sir.
Yeah, we will make that modification and we will be uploading that after this class. Immediately after this class, Sindhura and Vaishnavi will be uploading that. So then, of course, you plot your histogram there. You can, for example, plot the histogram of the input image there. Okay, then mark the Otsu based threshold value on that histogram. You can do that. And also plot the thresholded output image. Or plot means what it is, you just need to show that image. That's all. Display. Display the resulting segmentation. Okay, segmentation image. So here I would remove thresholded output image is there, but histogram need not be the output of the program. You call that function from another program. You write that function from another program. You pass this image. That output of that function will be the intensity value you are getting, and the output image also you should get it there, right? From the anyway histogram of the input image, anyway you have the input already, so you plot it. Threshold value, how much it has got, you just like the way These guys have shown here, okay, some line or whatever, you just show something there. There are different ways to plot a line or something like that on top of it, right? You just mark something like that and show it. So this one, they have given you two images, coins, buildings. I also asked you, since all of you are, I know, very seriously taking the notes in the class, I'm pretty sure. So you do one thing, you take a photograph of one of your pages. So as you could observe, at least from this one of these images, you could expect the page might be like, when you see the space, when you are writing something there. Okay, I'm not sure, the lighting is more, so I'm not sure whether you could see. You could expect some contrast. Better you take something written with the black color, or even it is fine when you anyway from one of the channels you take, or when you average it across all channels, you would see that color of your writing is in one intensity more or less, the other will be in another intensity, otherwise you would be reading it. So that piece of paper, so each one you have your own image there, own image of your running notes there. So your own handwritten notes, you take a picture, you do all the process required, create an input image, and then on that also you run this Otsu thresholding. So at the end of that, you should see the text. You should be able to extract the text here. See, there is, it's not a black and white on your left side, the image. It's on the right side, it's just 0, 1. There only you are able to separate the foreground from the background. Are there any questions or doubts? This I would give, the earlier 2 are for 15 marks. There were 3 questions roughly. Since one more assignment will be coming in the class, I kept it small one only. I did not, initially I thought I will teach 1 or 2 more like global thresholding, iterative thresholding, and put it there for 15 marks. Then I felt it's okay, you will be having something else. It's okay if you just get a feel for Otsu thresholding. Later you could read on your own if something is required. Okay, so this will be for 10 marks. Again, so very simple. After this, if you sit for 2-3 hours, as I repeat every class, next 2 hours are for me, you have given as a part of this lab. So sit there, work it out, and try as much as possible to finish it off, this assignment, in the next 2-3 hours. Okay, and then maybe report writing and all, you do it a little that if you want, you can do on some other day, but this also just 1 week time, 10 marks for this. Okay, that's how you go. These we will upload it. Even before uploading, you create this third image. Okay, you can even take a screenshot. Meanwhile, if you are so immediately want to do it, just take a screenshot of this scene now. Anyways, they will upload it in 1 hour, but again, just you take a screenshot of it. Also thresholding what you need to do. Or meanwhile, anyway, my TS will go ahead.
So we'll just upload it now, sir.
Yes,
We can
yes.
use the images also immediately.
Correct, right. Any questions or do you need any clarifications on what needs to be done or how it needs to be done? Do you have any questions? Is that clear? So next one, histogram equalization would come for you as a part of class programming assignment, as a part of MLIP course. Okay. No questions? Not even a single question? That means either I have explained well or everything is messy.
First case.
No, sir. Fine, sir.
Okay, good. Thanks. Okay, good. Yeah. So we'll stop here then. So you please go ahead. If you, I'll stop the recording part here.